So as I was saying before we got really cut off, in a parallel circuit, some of the current at this junction will go through R1. The rest will keep going. And then when it gets to this second junction, some of it will go through R2. And the rest will keep going and go through R3. The stuff that goes through R3 will come back. It will join up with the stuff that went through R2. That will join up with what went through R1. And the total current will come back to the power supply. In both cases, all the current returns. It's the voltage that's being dropped across each resistor, not the current. So in a series circuit, the total current that leaves the power supply is equal to what goes through R1, what goes through R2, what goes through R3. So I1 equals I2 equals I3 equals I total. Whereas in parallel, I total will equal the individual currents all added up. So I total will equal what goes through I1 plus R1 plus what goes through R2 plus what goes through R3. In other words, I total will equal I1 plus I2 plus I3. And if we added more resistors, we would just put them in there. So we could put here equals dot dot dot, and here we could put plus dot dot dot. People tend to think that the current changes. It's not the current that changes as the electricity is running a device. It's the potential difference. It's kind of like if you go to Crab Mountain. If you go to Crab Mountain, the battery is like the chairlift. So the battery or the power supply in the circuit is what's doing the work on the electrons to give them potential energy. Just like the chairlift at Crab Mountain is doing work on you to give you potential energy. So when you're at the top of the hill, if you're in a series circuit, then it means you can come down the hill by doing 3 little hills, R1, R2, and R3. And everyone who goes up the chairlift, if this is the only route, they have, they all have to come down. The battery is putting in some voltage V total. When you come down R1, you drop V1. When you come down R2, you drop V2. When you come down R3, you drop V3. And then when you get to the back to the bottom, you have no potential difference left, no voltage left. But everybody who's up the chairlift should come down the hills. It's not like some of them are disappearing in R1, R2, and R3. That would mean there was an abdominal snowman or something on the hill picking skiers off, and that's not good for return customers. But if you go up a chairlift across a battery in a parallel circuit, that means that so the chairlift or the battery is still doing VT, V total. But when you get to the top in a parallel circuit, it's like you have 3 hills to choose from. Hill number 1, hill number 2, and hill number 3. And so you could come down R1 and in so doing drop V1, or you could come down R2 and in so doing lose voltage V2, or you could come down R3 and lose voltage V3. In the end, everybody who went up the chairlift has to come down one of the 3 of them. So the total that went up has to equal the sum. Whereas over here, the total that went up has to equal what goes through each of these. In series, the currents equal, and in parallel, the currents add up. But if you think of voltage in series, the voltage should add up. The total voltage that was given by the battery has to equal what's dropped over each hill added together. And it's just the opposite in parallel. You have to get back to the bottom with 0 volts, so that means V1 must be equal to V2, must be equal to V3, must be equal to V total. So they're just the opposites. In series, the currents equal, the voltages add up. In parallel, the voltages equal and the currents add up. Okay? I think that's all you probably need to know to be able to do the rest of the questions on the electrostatics review sheet. Okay? And so that's what I'd like you to do for tomorrow. I will post a video with the answers to the first 9 because I think that's what I assigned already. Okay? So if you would now do numbers 10 to 18, that would be wonderful. Thank you.